Hello, students, and welcome to another video. I'm your teacher, Mr. Flynn, and today we're going to be talking more about radiation and ionizing radiation. So there's two vocab words I want you to pause the video and write down, okay? So radiation is a term used to describe both electromagnetic radiation and high-energy particles. So we've been talking a lot about different particles and types of radiation, and this is where we're going to differentiate some of the concepts we've learned. So we've learned that there's the electromagnetic radiation. Okay, that includes energy such as radio waves to microwaves, infrared, visible light to ultraviolet light, ultraviolet light. We have gamma X-rays, gamma rays. Okay, so we've got these different types of electromagnetic radiation, and it's all based on the wavelength. So radio waves are going to be real long, while gamma rays are going to be really short. They're going to have a much more higher energy than radio waves do. As you're sitting watching this video, there are radio waves and microwaves shooting through you right now. Your phone uses microwaves. The towers that you send out radio signals so you can listen to the radio in your car or in your house are traveling in waves from the electromagnetic spectrum. Okay, so they're traveling. They're just pure energy. Okay, they don't have particles. No particles. It's just energy. Has the ability to change matter in ways. Okay, and then the other type are the high energy particles, and that includes the alpha and beta minus and beta plus. Okay, and the beta minus is also known as an electron, and a beta plus is also known as a positron. All right, so this is an electron, this is a positive electron, and then we've got an alpha particle, which is a helium atom, like this. Okay, so we've got these three types of fast-moving particles. They're actually matter. They are made of matter. Okay, and then these are not made of matter. They're electromagnetic. Okay, it's just pure energy. Okay, and the question we ask is, well, which of these types of radiation are dangerous to us? And the word we use is ionizing radiation, or has the ability to knock electrons off of atoms to produce ions, okay, which is damaging to living organisms, et cetera, et cetera. Okay, now let's think about this. Earlier in the year, we learned about how if we have an atom, we'll use the Bohr model here, okay, and we have an electron, and we have this wavelength of light. We'll say it's red light because it's a red line, and it has just enough energy to make it move up an energy level like this. And as it falls back down, it will re-release that light. Okay, now what happens if it was something much higher in energy? What's it going to do? Is it going to jump one level? It may just completely disappear. It's now ionized. Okay, and think about something like sodium. Okay, it has one valence electron, and if something with enough energy hits that electron, it can absorb that energy and go away from that atom. And now that it's missing an electron, it's going to have a positive charge. Okay, it's been ionized, meaning that atom, that neutral atom, it now has a charge to it because it lost that electron. So the ionization energy has the ability to knock electrons off of atoms. Okay, so we're literally, that high energy is being deflected off that atom. And the different types of radiation that are ionizing are all of the fast-moving particles are. These are all ionizing. Okay, they can all knock electrons off. But in the electromagnetic, there's only two that we're worried about, and that's X-rays and gamma rays. Okay, the rest of these, we're fine. Visible light, that's how we view the world around us. Infrared, giving off this heat. Microwaves, used in our phones, used in our kitchens. Okay, ultraviolet is what causes us sunburns. Okay, we're starting to get into the danger zone, but the X-rays and the gamma rays are what we need to be most worried about as far as absorbing. So if we look down here, they have a nice chart that shows the relative danger of each of these particles. So alpha particles are the most dangerous because they're the largest, but they can be blocked by a sheet of paper. Okay. Beta particles can travel through a sheet of paper, through your skin, even and then to aluminum plate that stops it. Okay. X-rays can travel through all of these materials all the way to lead. Okay. That is why you wear a lead suit when you go and get your X-ray done on your arm or whatever bone you've broken. If you broke your arm, you'd lay on the table and they'd put a lead suit or blanket on you to help block that radiation from hitting your internal organs. Because all you want to be exposed to is that damaged area of your arm where we're trying to get an image formed. Okay. And gamma rays and X-rays are pretty, and then neutrons, we're not going to go into too much about neutrons, but they can travel through more materials. Okay. But the ones I really want to know are the X-rays and gamma rays, the beta particles, positrons and electrons, and alpha particles. And this is just a reference to how dangerous they can be. Okay, so the ones that we should be worried about the most are X-rays and gamma rays and beta particles. Okay, all right. Thanks for watching. Until next time.